All right, so, okay, this is the equivalent. So this is the long distribution to expand it. Y plus 3. Oh, it's y plus x, you guys. Hello, I already messed up the start. Y plus x. All right, you got a cube, so there's 3 of them. All right, so let's take the expansion of the first 2. So y squared, xy, xy, x squared. Okay, these 2 get added together. Y squared, 2xy plus x squared. All right, so this was last year. This year, we're now adding more binomials to distribute with. You always write them alphabetical, so even though you want to go yx, it's xy, you write them in alphabetical order. And you just place the 2 variables together. So far, so good? Keep going? Okay. When you're yeah, okay. So now you have to continue to expand. So y squared y cubed, y squared times x is xy squared. 2xy, okay, so 2xy times y is 2xy squared, because there's 2 y's, right? 1 is 2. All right, and then plus 2x squared y, because there's 2 x's, 1 y, right? And now, I'm running out of space, plus x squared y plus x cubed. So talking while you're doing this assignment is not ideal because they're just little numbers that you can, that you just want to be careful and make sure you're adding your exponents correctly. So just slow down, kind of focus on what you're doing. You guys are all capable of adding, but definitely if you're going 2xy, that's 2xy, there's 2 y's. And then here, 2xy times x, 2x squared y. Just human error. Okay, you're not done. Now if you combine it out, I get y cubed, xy squared, so 1 plus 2 is 3xy squared. X squared y, that's 3x squared y. And then, of course, my x cubed. And so this is the expansion. Okay, that was a long way. Let's now look at Pascal's triangle binomial theorem and just cut the work. Okay. All right, look, one thing to note though is they're a little off. These are lined up nicely, so the exponent is with that row. This is with this one, right? It's a little off center, right? This goes with this one. You can see the 4s with the 4, the 5s, and the 5s and the 10s, right? Okay, and then the 6s aren't there. It would be, well, you know what? We'll do that one together. We'll come down and do this one. Okay, so here, same thing. Just know that the 6, it's not written. It would go down below, okay? So they're a little bit, it's a little off, okay? All right, look. This is your exponent, 0, 1, 2, 3, 4, 5. This is the exponent they're speaking of, 2, 2, 3, 4, 5, 5, 3. Okay, so let's just talk about the one we just did. All right, so we have a 3. So we would be looking at exponent 3. Now, we'll kind of build this, but this is where we are. Okay, we're right here. That a plus b quantity cubed. All right, Pascal's triangle, once you understand how it works, you don't need any of this. Like if you have a student that's going in to say their SATs, they don't need a reference. You're never given a reference on a math test, because if you truly understand it, you need none of it. It's like, I don't know, it's like counting to 10. Like they don't have to start you off at 1, 2, 3. You automatically know how to get to 10. Okay, so this is the way it goes. You always start with the 1, right? Because anything to the 0th power is 1, right? Okay, so the way it works is there's your 1. You're now going to build the Pascal's triangle. You're going to build it down like a pyramid. Okay, because you're at the top. And you add 1 more to the left and to the right. Well, I got nothing else to write, so it goes 1, 1. That's why it's kind of like you just know, like you're never given a reference on a math test. You add 1 more, and it's always 1. But then this comes with 2, because 1 plus 1 is 2, and then you add another 1. So this is row 0, this is row 1, this is row 2, or exponent. 0, 1, 2. Okay, so now go to the third. 1, this is 3, 3, and then 1. And that's just how it's built. So then 1, 4, 6, 4, 1. And then 1, kind of reminds me of a Christmas tree. 5, 10, 10, 5, 1. Okay, and that is your Pascal's triangle. So that's what we just made. These are your coefficients to your terms that we're going to use to multiply. Okay, so Pascal's triangle doesn't have the terms. It's just the coefficients. Bless you. Because the binomial theorem, if you understand how to count down and count up, binomial expansion, I keep calling it theorem, binomial expansion, you don't necessarily need all these A's and B's. If you can build this, you're set. Okay, so where do these A's and B's come in? Okay, so if you say have x plus y and say it's squared, you start at 2 for the first variable and you work your way down. X squared, x1, x0, 2, 1, 0. So you're working your way down. The other variable, the second term, works its way up. So this is y0, y1, y2. So that you're left with x squared plus xy plus y squared. So if you have, say, x, oh, well, this is, okay, well, this one, we did y. Did I do 5? Yeah, 5. All right, so if we look at the 5 that we just did, it's y plus x cubed. The first one starts at 3, and it goes downward. 3, 2, 1, 0. The first term goes up, and you start at 0. X to the 0, x to the 1, x to the 2, x to the 3. So the first term is downward. The second term is increasing. Okay, so what do I get here? I get y third, xy squared, x squared y, x cubed. Okay, but now what about your coefficients? Well, if you're in the third row, remember this is row 0, 1, 2, 3. You'll know because it has the 3's in it. It goes 1, 3, 3, 1. So it is 1, 3, 3, 1. And that's exactly what we got when we solved it by hand. Y cubed plus 3xy squared plus 3x squared y plus x cubed, and that's exactly what I have. Now, how does it get more complicated? By adding negatives and other coefficients, then it starts getting a bit longer. So we're going to do another one. I'm going to stop this video just because otherwise I'll try and make one video, one problem. Because this one's kind of long actually. I think it's probably at least 10 minutes. Let's see.